Okay, so we should be able to get chapter 19 cranked out in 3 recitation videos. Chapter 19 deals with functional groups that contain nitrogen. Primarily we're going to focus on amines. So an amine is where you have a nitrogen connected to one or more alkyl groups. So we need to know IUPAC, systematic naming, and also trivial naming. You should know about nitrogen inversion. But one of the more important aspects and properties of nitrogens, of amines, is that the nitrogen is going to have a lone pair. So this is the main property of amines, and that is that they are basic. So base is a 2-electron donor. Specifically 2 electrons donated to a hydrogen. 2 electrons donated to any other element makes it a nucleophile. So amines, because of the lone pair on the nitrogen, are bases and nucleophiles. Right? So you already know this. Amines, or like ammonia, is a base, whereas water is neutral. That's because nitrogen is a better 2-electron donor. The difference there between the elements is nitrogen less electronegative. Electronegativity is how tightly you hold on to electrons, so more electronegative means less basic. So when it comes to basicity of nitrogens or basicity of amines, there are 3 factors that you need to be aware of. So only 3. The first is all alkyl substituted amines are more basic than ammonia. So this is explained by the stability of the ammonium cation produced upon protonation. So you know that alkyl groups make a positive charge more stable. Normally we do that in terms of carbocations. Here obviously it's not a carbocation, it's an ammonium cation. So more alkyl groups give you a more stable ammonium cation. So the primary amine is going to be more willing to be protonated than ammonia itself. So this is summarized in the top of our end of chapter summary. So lone pair on the nitrogen being donated, it's a nucleophile and a base. Primary amines, stronger base than ammonia, and that's because of alkyl substitution. So all alkyl substituted amines, stronger bases than ammonia. The next thing is resonance. So we have to then consider, how does resonance impact the lone pair? The answer is resonance is always stabilizing. So if the lone pair on the nitrogen is involved in conjugation, if it's involved in resonance, so if it's adjacent to pi bonds, those pi bonds could be an aromatic ring like we have in aniline. It could be adjacent to a CO double bond like we would have in an amide functionality. Doesn't matter, that lone pair will be stabilized by resonance, and if it's stabilized, it's going to be less willing to be protonated. So for example, aniline, this lone pair conjugated with the pi cloud around the ring, the act of protonation, if these 2 electrons get protonated, we've now removed that effect. So resonance is stabilizing, which decreases base strength. Most extreme form of that, for example, is pyrrole. The nitrogen on your pyrrole, the lone pair, is required for aromaticity, sort of the ultimate stabilization. Protonation of that lone pair would destroy your aromaticity. Obviously that's bad, not favorable, and that's why we see that pyrrole is such a terrible base. So we summarized that here by saying primary amines are stronger bases than amides. This is because that lone pair on the nitrogen is conjugated with the CO pi bond. So any type of conjugation, any type of resonance, any type of aromaticity, and that lone pair is used, that's going to give you a decrease in base strength. Basically, this lone pair is stable and happy as is, doesn't want to get protonated. Then, the only other effect that you need to be aware of is hybridization. So, conjugation effect is most important. Here, this is then applied if everything else is equal. So here we have three compounds that all contain a nitrogen. Those nitrogens each have a lone pair, but the difference in base strength is tremendous. The difference here is just hybridization. The hybridization of the nitrogen impacts the hybrid orbital in which the lone pair is held. sp hybrid orbitals are of lower energy, meaning more stable, than sp2, and sp3 is of highest energy. So high energy electrons are more reactive. So the reactivity in this case is base strength. So this lone pair, because the nitrogen is sp3 hybridized, is more basic. So sp3 most basic, sp2 next. Sp hybridized nitrogen means lone pair in an sp hybrid orbital, most strongly held, therefore least basic. So that's summarized here. Primary amine, which really is sp3 nitrogen, is a stronger base than the sp hybridized nitrogen in a nitrile. Those are the only three things you know to discriminate between the base strength of amines. So we can illustrate that with some exam questions. It doesn't matter what exam 2 you pick. Going back in history, they will all have some type of base strength question. So this is Spring 15, Organic 2, find the strongest base. So part A, for something to be a base, it has to have a lone pair, has to have 2 electrons to donate. So methane does not have a lone pair. We then have to decide between the lone pair on the nitrogen or the lone pairs on the oxygen. We just said that nitrogens are more basic than oxygens, so that lone pair on the nitrogen in A makes it the most basic. Part B, nitrogen, nitrogen, nitrogen. Each of those nitrogens have a lone pair. None of those nitrogens have lone pairs that are conjugated, so this is then a hybridization effect. So sp3 nitrogen versus sp2 nitrogen versus sp. Your summary chart tells you that the sp3 hybridized nitrogen is most basic, so this would be the answer. Part C deals with resonance. So this nitrogen is in the lone pair on this nitrogen is in conjugation with both of these aromatic rings. Here the lone pair on the nitrogen is in conjugation with this pi system. There's no pi system here. Here the lone pair on the nitrogen is not conjugated. Notice that these pi bonds are further away. So this is basically double resonance. This has single resonance. This has no resonance. Resonance makes it less basic, so the strongest base in this trio would be that one. Part D, this is a 6-pi aromatic system. Lone pair on this nitrogen is not involved in aromaticity. This is a 6-pi aromatic system. The lone pair is involved in aromaticity for this pyrrole. Next to it, N-methylpyrrole. This nitrogen has a lone pair, is involved in aromaticity. So lone pair involved in aromaticity, lone pair involved in aromaticity, lone pair not involved in aromaticity. This one is the most basic one. Part E, 6-pi aromatic system, lone pair involved in aromaticity. 6-pi aromatic system, lone pair involved in aromaticity. 6-pi aromatic system, one of the lone pairs on the oxygen is involved in aromaticity, but oxygen has 2 lone pairs. So you could protonate this oxygen and still keep your 6-pi aromatic system. And that's why that one would be the most basic. So we can do the same type of thing. Look at a different exam. different exam, same concept, different form of questions. Now circle the most basic atom. So amine, alcohol, alcohol, ether. If we're looking for most basic, nitrogen has a lone pair, the oxygens have a lone pair, nitrogen more basic than oxygen. This nitrogen is most basic. Here we have a question. Oxygen, nitrogen, nitrogen, and nitrogen, those have lone pairs, but they're all potentially basic. This is a lone pairs on oxygen, but that oxygen is conjugated with the aromatic ring. This is a nitrogen with a lone pair, that lone pair conjugated with the aromatic ring. This is a nitrile, one lone pair on the nitrogen, not involved in conjugation. This is a nitrogen with one lone pair, not involved in conjugation. So we're now going to, conjugation or resonance decreases base strength, so now our choice is between these two. This is an sp3 nitrogen, this is sp. Our summary chart tells us sp3 hybridized nitrogen is more basic than sp. So this would be the most basic atom. Part C, lone pair on this nitrogen, lone pair on this nitrogen. This positively charged nitrogen with 4 bonds has no lone pair. So it's now just a choice between these two nitrogens. This ring is a 6-pi aromatic system. The nitrogen here, that lone pair is required for aromaticity. This nitrogen has a lone pair not required for aromaticity. So this is a nitrogen whose lone pair, if you protonate it, destroys your aromaticity. That's not good. This nitrogen has a lone pair, protonate it, still be an aromatic system. Therefore, this nitrogen would be the most basic. So there you go. That's how base strength is impacted when we're talking about different nitrogens.